Hi everyone and welcome to Smart Culture Education. This is the place where we make learning simple, clear and engaging. If you're new here, don't forget to subscribe so you can join us on this journey of mastering maths, science and more. Let's investigate how sodium silicate undergoes a condensation type polymerization reaction when we add ethanol. So you will see how we transform a clear liquid into a thick elastic gel. I'm starting by heating some water using a spirit burner and beaker. The reason we warm the water is so that we can warm up the sodium silicate solution gently. Sodium silicate becomes less viscous and easier to work with when it's slightly warm. The warming step also helps the silicate ions move more freely, which encourages a faster polymerization reaction later. I'm now placing the sealed container of sodium silicate directly into the warm water. I only leave it here for a minute or two, just long enough to reduce its viscosity. By warming it slightly, the reaction with ethanol becomes more visible and also easier to stir. I'm now pouring about 20 milliliters of the warmed sodium silicate into a clean glass beaker. Now I measure 5 milliliters of ethanol using a measuring cylinder. Ethanol plays a key role in this reaction. When we add it, it disrupts the water structure around the silicate ions and forces them closer together. As soon as the ethanol mixes with the sodium silicate, the reaction begins. I'm using a spatula to stir the mixture, and look at what's happening. The mixture starts to thicken. It becomes gel-like. You can see elastic rubbery strands forming on my spatula. So this is the silica polymer forming. So why is this happening? Here's the science behind the reaction. Sodium silicate contains silicate ions surrounded by layers of water. And when ethanol is added, it reduces the solubility of the silicate ions. The silicate units lose their hydration shell and begin to link together. As they bond, they form a three-dimensional polymer network. Water molecules are released as a byproduct, which is why you can see a clear liquid remaining in the beaker. That is the water formed during the condensation type process. I'm lifting some of the gel with the spatula so you can see it clearly. Look at this consistency, thick, elastic, and solid. This is the final polymer product. And that completes the demonstration. We heated the sodium silicate to reduce its viscosity, added ethanol, and watched how the silicate ions linked together to form a polymer, releasing water in the process. Thank you for watching today's video on Smart Culture Education. If you found it helpful, don't forget to hit the like button and subscribe to the channel. And if you want to stay updated, tap the notification bell so you never miss our next lesson. See you in the next video.